1.2 is a fairly short section. We're just going to be reviewing some properties of our rectangular coordinate system. Remember, our rectangular coordinate system is where we do our graphing of points x and y. Typically when we graph, we do this in alphabetical order. So we're going to graph first our x value and then our y value. Looking at this graph, our horizontal line is our x axis, and the vertical line would be our y-axis. Where they cross is the point 0, 0, so the x value is 0, the y value is 0, and that is what we call our origin. When we graph, we always go in the direction of x first, which would be a horizontal direction, and then the vertical direction y. Our graph is split up into 4 pieces, which we call quadrants. The first quadrant, which I'll just label Q1, is where the x and the y values are positive. If we go counterclockwise, we'll have quadrant 2, x is negative, y is positive, and then below we'll have quadrant 3, both are negative. Quadrant 4 is where x is positive and y is negative. So for example, if I was to go in a -5 direction on the x-axis and then go up 4 or +4 in the y, I would get to this point, which I would label -5, x is first, comma, y is +4, and that would be in quadrant 2. Notice that the origin is on the axes, so the origin is not in a quadrant. Points on an axis are not in a quadrant. Points within axes are in a quadrant. In example 1, we're just going to graph points and state what quadrant, if possible, that they lie. Part A is the point -1, 4. So we're going to go -1 on the x and then up 4 on the y to get to this point -1, 4. Label it -1, 4. And this lies in quadrant 2, so I'll just write Q2. Part B is the point -3, 0. So x is -3, y is 0. So we're on the axes, and this would be -3, 0. Since it's not in a quadrant, I'm just going to write no quadrant. All right, part C is the point 2, 1. So +2 on the x, +1 on the y. And we're in quadrant 1. So let me label this 2, 1. D is a 0.5, -4.5. So it's a +5 on the x. We're going to go down 4.5. So 1, 2, 3, 4 and a half to get to the point 5, -4.5. That would be in quadrant 4. The next property we're going to look at involves the distances between 2 points. If we look on our graph, and I look at the distance between the point 2, 1 and 5, -4.5, I can drop a right triangle, and the longest side would be the distance between the 2 points. So that longest side in a right triangle is called our hypotenuse. Let's go down below and look at our Pythagorean theorem. In the Pythagorean theorem, we label the shorter legs, typically A and B, and then the longest side we label C, and that is our hypotenuse. Again, that's going to represent the distance between 2 points when we look on a graph. So the formula that we're all familiar with is that a squared plus b squared is equal to c squared. So notice if I just wanted to find c, and I took the square root of both sides, a squared plus b squared, That's going to be equal to the square root of c squared. And since these values are all positive, I don't have to worry about absolute values. This is just going to be equal to c. So again, when we look at our graph, this will be the distance between 2 points. Let's use our Pythagorean theorem to find the length of an unknown side. Here we have a is 10 in part A and b is 5. So I'm looking for my c, my hypotenuse. The formula is that a squared, so 10 squared, plus b squared, which is 5 squared, is going to equal my c squared. That would be 100 plus 25, or 125, is equal to c squared. And c is going to be the square root of 125. So if possible, I want to write that in simplest form. Now 125 is simply 25 times 5. So since this is 25 times 5, the square root of 25 is simply 5. And my c value is 5 square root of 5. One more example. Part B, we have a is 7 and c is 5 times the square root of 2. So the formula is a squared, so 7 squared, plus b squared, so that would be our missing value, is equal to c squared, or 5 times the square root of 2 squared. We have 49 plus b squared is equal to, now remember the square on the outside is distributed to both the 5 and the square root of 2. So 5 squared is 25 times square root of 2 squared is just 2, and this is 50. B squared is then 1, so our missing side is b, which is equal to 1. And now going back to the idea of a distance, the distance formula comes from the Pythagorean theorem. So let's say that we have 2 points. We'll call them P and Q. And we want to find the distance d between P and Q. So P is going to have an x and a y value that we'll call x sub 1, y sub 1. Q will have x and y value. We'll call those x sub 2, y sub 2. So the formula is simple. All we have to do is subtract the x's and square them, subtract the y's and square them. I don't think I like black. I like green. Going back to the idea of a right triangle, when we take the difference between the x values, that would be like our a value in the Pythagorean formula. And the distance of the y's, we could call that a b value. And since we're square rooting a squared plus b squared, our distance would represent the hypotenuse, or the c value. Now something to remember with the distance formula is that the order of the subtraction actually doesn't matter because we're squaring. So we could have a sub 1 minus a sub, or x sub 1 minus x sub 2, or x sub 2 minus x sub 1. Similarly with the y's, order doesn't matter since we're squaring them. Let's go ahead and use that formula in example 3. We want to find the distance between the points. So one point is negative 2, 5, and the other is 4, negative 3. So remember, order doesn't matter. I'm simply going to take the x values, which would be a negative 2 and a 4. I'm going to subtract them. So negative 2 minus 4, and I'm going to square them. Plus 5, negative 3, subtract. So 5 minus a negative 3 would be a plus 3, square, and then I'll take the square root of all of that. So negative 2 minus 4 would be negative 6 squared, or 36, plus 8 squared is 64. I have the square root of 100, which is simply 10. And that would be the distance between these 2 points. We'll do one more example. One point is negative 6, 10, and the other point is 6, 5. I want to find the distance between these 2 points. I'm going to subtract my x's. So negative 6 minus 6, and then square plus negative 10 minus 5 squared. And then I will take the square root of all of this. This would be negative 12 squared, which would be 144, plus negative 15 squared would be 225. I sound like I knew that, but I'm actually putting that in a calculator. Adding those two, I get the square root of 369. That is divisible by 9. So I can simplify this further because this is 9 times 41, which would give me 3 square root of 41, and I believe that is as simple as I can get the distance between those points. Right, so the final thing we want to talk about is not just the distance between 2 points, what is the halfway point between 2 points, or the midpoint between 2 points? So when we talk about the midpoint between 2 points, it's going to be a point. So we're going to need to use parentheses to indicate that we have a point. And to compute the midpoint, all you're going to do is add your x's, divide by 2, add your y's, divide by 2. Order does matter here because this is a point. We want to make sure that we compute our x's first and then our y's. We'll look at those same 2 points that we just found the distance for. And this should be example 4. So many typos. So if we want to find the midpoint between these 2 points, all we have to do is add the x's. So we have a negative 2 and a 4. So add them, divide by 2, comma, the y's would be 5 plus a negative 3, divided by 2. Again, this is a point, so it needs to go in parentheses. We will have 2 over 2 or 1, comma, 2 over 2 is 1. Okay, so the midpoint, which again is a point, it's the halfway point between those 2 points, would be the point 1, comma, 1. Last example, in part B, we have point negative 6, negative 10, and 6, 5. So if we add our x's, it would be negative 6 plus 6 divided by 2, comma, add the y's, negative 10 and 5, negative 10 plus 5 divided by 2. Again, this is a point. So I get 0, comma, 5, negative 5, sorry, over 2. So that would be the midpoint between our 2 points. And this is a very short section, so we are actually done with 1.1.